Hey, hello folks, this is Mr. Walker coming to you with our round of notes for today. We are dealing with the different triangle theorems other than our exterior and sum theorem. So let's take a quick look at these. Now, for our first one that we have coming up, this is the triangle inequality theorem. This one is specifically dealing with the sides of our triangle. So for this to work, we have to understand that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So for the sides of a triangle to meet, this inequality has to be true. When you add any two sides, it must be bigger than the third side for it to be a triangle. If they're smaller than or equal than, that means that you're not having a triangle. This could be a different type of shape you're dealing with. So let's deal with our first one. If you're looking at the example off of this triangle here, our first one's going to say that AB plus BC has to be bigger than or greater than AC. So AB 6, BC is 8, and those two are greater than 10. So if you add any two sides, it has to be greater than the side that you didn't add. All right, for our next one, if I'm looking at AC, that's going to be added with BC to be bigger than AB. So AB 6, so that means that 8 plus 10 has to be bigger than 6. Obviously, this is true. That's because this is going to be a triangle. Now for our next one, if we're dealing with BC being the side that we're trying to get bigger than, that's AB plus AC. So that means that we have 6 plus 10, and 6 plus 10 is greater than 8. So that means that these lengths give us a triangle. All right. Now we talked about this briefly when we started going through classification, but it's important to know that when you're looking at the side lengths and trying to make a determination of the angles, or vice versa, you should know that the largest side of a triangle is opposite the largest angle, and the shortest side is opposite the smallest angle. So you can go backwards or forwards with this. Longest side to longest angle, or uh, longest angle to longest side. So in this triangle here, we got three sides, 10, 8, and 6. Our biggest side here is 10, which is AC. The angle that's opposite AC is the letter that's not a part of AC, which would be B. So B is our largest angle. It's opposite our side, so that makes it the largest one. Now our smallest side is AB. The corner that's not touching AB is C, so that means that angle C would have to be our smallest angle. Okay, two theorems down, two more to go, folks. All right, first up we got on this one is the isosceles triangle theorem. Now this is dealing with what we know about isosceles triangles. So, isosceles triangles have two sides. So it's important to know that the base angles of an isosceles triangle are congruent. Now, we're looking at a triangle that's isosceles. The point where both of our congruent sides meets is called the vertex angle. And then the angles that are opposite our two congruent sides are called the base angles. So if AB is congruent to CB, then that means that these angles, C and A, are both congruent. Conversely, if C is congruent to A, then AB is congruent to CB. So backwards and forwards, just like how we had with the last bit of work that we had. So it has to work both ways. If it doesn't, then you got a different situation here. All right, last thing we got to talk about are our side and angle relationships in triangles. So when we're dealing with this, if two triangles have sets of congruent sides, then the one with the larger included angle will have the longer side. So this one's a little confusing. It doesn't pop up too much for the things that we're doing, but it's important to know if you have two triangles like how we do with A, B, and C, and X, Y, and Z, these guys happen to have two pairs of congruent sides. This one, and this, and this. For you to look at these two and you wanted to make a determination about the size of their angles, this angle B, because it's opposite side, that's 10, and this angle Y, that's opposite this side, 13. Since 13 is the larger of our two sides, that means Y is going to be the larger of our two angles. So that means that the measure of angle Y is going to be bigger than the measure of angle B because the sides that are opposite of them are larger and smaller and such. Okay? So these relationships will go through, help you to set up different things as we go and deal with triangles further. All right, people, on the right side, we got some triangle inequality theorem that we got to practice. I'm going to give you 3 lengths of a triangle. Well, 3 lengths of sides to see if they're going to form a triangle, actually, because they're not triangles yet. So, pause it, take a look at it, and try it. If you don't, that's also cool. All right, people. Hopefully you paused it and gave it a try. Let's see if this works. Our first one, we have 5, 5, and 11. Off the rip, I can automatically say this is no, because if I add 5 plus 5, it's not larger than 11. There's no need to go hard in the paint with this. This one is not going to be a triangle. Over here, we have B, which is 4, 8, and 7. If I take a look at those and I set up my inequalities, 4 plus 8 is larger than 7. 7 plus 8 is larger than 4, and 4 plus 7 is larger than 8. All that works. Over on C, this one would also work. Reason being, even though, hold on. I think we actually have a typo here, folks. Oh, sorry about that. This one actually would not work. Because if I have 1 plus 1, that's 2. 2 is not larger than 3. So let's go through, let's cross that out. That is a no. Okay, cool. All right, next one we got 10, 3, and 8. So 10 plus 3, that's larger than 8. 8 plus 3, that's larger than 10. And 8 plus 10 is larger than 3. That's going to be a yes. For our next one, we got 1.5, 4, and 2.5. 1.5 and 2.5 add up to 4, which means that this one's going to be a no. Okay? And then for our last one, I already know that because I see 1 foot, 10 inches, 6 inches. You got to keep this in mind as we go through. 1 foot is 12 inches. So 12 plus 6, that's going to be bigger than 10. 10 plus 6 is bigger than 12. And 10 plus 12 is bigger than 6. So this one would also be a triangle. I decided to throw you a little bit a harder one. Sorry about that. All right. We got these 4 on the bottom that we got to practice with. So let's go through and let's take a look at explaining them. All right, over here on A, I seem to have 2 side lengths here that are marked the same. And I also see that these angles inside are also marked the same. So since these 2 have the same arc and these sides have the same mark, that means that these are equal and so are these. Since these angles are equal, this side here, 4x minus 8, and this side here, negative 2x plus 13, those 2 are equal to each other. Since they're equal to each other, we can set them equal, solve for x, and then we're all good to go. So this would end up going through. We got 6x equals 21 because you added the 2x from the right, you added the 8 to the right, and we get a 3.5. Okay. Easy peasy, lemon squeezy. All right, next one we got two angles here. We got X on the triangle up top. We got 52 on the triangle on the bottom. Things that we got an idea of. This angle over here is also 52. And that's because this side and this side are both marked the same. If this is 52, we also got to remember our stuff from our previous units. This angle here is a vertical angle, which means that this is also 52. If that's 52, that means this is also 52 because these two sides are marked the same. These angles here are both going to be the same. So I want to go and figure out what X is. We're going to do 180 minus 52, giving us 76. All right, next one we got. We're going to be using greater than or less than symbols to tell me which side is bigger. So AD, which is this side here, is opposite 57. CD is opposite 49. Since 57 is the larger of our two angles, that means that AD has to be the larger of our two sides. All right, last one that we got here, and then we're home free, folks. We got to list the order of these sides from shortest to longest. In order for us to know that, we got to know what all three of the angles are. So if we take those two angles and put them into our triangle sum theorem, we subtract them from 180, that tells us this angle here is 67. And now that we have this, we can list out our sides from shortest to longest. Our shortest side is across from our smallest angle. So that means AT is going to be first, followed by CT, followed by AC, because it is across from our largest angle. All right, folks, managed to get through here good and easy. I appreciate you working with us, and I will catch you later.